Welcome to ZoomInData, your go-to channel for in-depth data engineering, analytics, and modern cloud technology interview preparation. In this video, we dive deep into the top 25 Microsoft Fabric Event Streams interview questions for 2025. Perfect for data engineers, real-time analytics professionals, and anyone preparing for Fabric real-time intelligence roles. We cover core concepts, real-time ingestion, sources, transformations, integration with Lakehouse and OneLake, monitoring, scaling, security, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What are event streams in Fabric? Event streams in Microsoft Fabric real-time intelligence are no-code items that enable ingestion, transformation, and routing of real-time events from sources to various destinations. They provide a visual drag-and-drop editor for defining processing logic, including filtering, aggregation, and enrichment without writing code. Backed by Azure Event Hubs, event streams support Kafka-compatible endpoints for seamless integration with existing streaming applications. Enhanced capabilities allow advanced transformations across all destinations, with derived streams bridging complex routing scenarios. 2. How do event streams support real-time ingestion? Event streams ingest continuous or discrete events via built-in connectors, custom endpoints, or Kafka protocol in real time. They support push-based ingestion from sources like Azure Event Hubs, IoT Hub, and third-party platforms without polling delays. Live View mode visualizes incoming events instantly, with data preview and runtime logs for immediate validation. Integration with Real-Time Hub enables discovery and subscription to streams for low-latency consumption. 3. What data sources integrate with event streams? Native sources include Azure Event Hubs, Azure IoT Hub, and Fabric Workspace Events for Microsoft ecosystem integration. Enhanced capabilities add streaming connectors for Amazon Kinesis, Google Pub, Sub, Kafka, and CDC sources like MongoDB. Custom app endpoints support HTTP or Kafka ingestion from any external application or system. Discrete event sources capture Fabric item events or OneLake changes for internal monitoring. 4. How do event streams handle high-volume data? Built on Azure Event Hubs, event streams scale to millions of events per second with partitioned throughput. Configurable throughput levels and capacity units optimize for high ingress and egress volumes. Batching to destinations like Lakehouse ensures efficient handling of large-scale streams. Autoscaling in underlying capacity adjusts resources dynamically for peak loads. 5. How do event streams ensure low-latency processing? Direct ingestion modes and in-flight transformations minimize processing delays before routing. Event processing before ingestion in Lakehouse enables sub-second analytics on raw streams. Optimized connectors and query folding push operations closer to sources where possible. Live View and real-time previews provide immediate feedback on stream latency. 6. How do event streams integrate with Lakehouse? Event streams route events directly to Lakehouse KQL databases for real-time querying and analysis. Direct ingestion mode supports event processing before or after landing in tables. Multiple destinations allow branching streams to different Lakehouse tables or databases. Integration enables low-latency KQL queries and real-time dashboards on streamed data. 7. How do event streams manage message ordering? Partition-based ordering from sources like event hubs preserves order within partitions. Kafka-compatible topics maintain order per partition key for consistent processing. Transformations in enhanced mode respect input ordering unless parallel operations are applied. Destination mappings ensure ordered delivery to ordered sinks like EventHouse. 8. How do event streams handle data loss prevention? At least once semantics with retention policies buffer events for recovery. Configurable retention up to 90 days allows replay of missed events. Fault-tolerant routing and acknowledgements from destinations prevent drops. Runtime logs and monitoring detect ingestion gaps for proactive mitigation. 9. How do event streams support fault tolerance? Underlying Azure Event Hubs provide geo-replication and high availability. Pause. Resume capabilities on nodes maintain state during maintenance. Multiple destinations enable redundant routing for failover scenarios. Autoscaling and throttling prevent overload-induced failures. 10. How do event streams integrate with OneLake? Routing to Lakehouse destinations lands data as delta tables in OneLake for unified access. EventHouse with OneLake availability exposes streamed data in delta format without duplication. Shortcuts and direct lake mode enable seamless querying across Fabric workloads. Real-time events become immediately available for batch and streaming analytics in OneLake. 11. How do event streams manage schema evolution? Dynamic schema inference adapts to changes in incoming event structures. Mapping rules in destinations handle schema drift during ingestion. Transformations allow explicit casting or column additions for compatibility. Preview and validation in edit mode detect schema issues before publishing. 12. How do event streams support windowing operations? Event Processing Editor includes SQL-based operators for tumbling, hopping, and session windows. Aggregation and grouping over time windows enable real-time metrics computation. Enhanced mode applies windowing before routing to any destination. Integration with KQL in EventHouse extends advanced windowing post-ingestion. 13. How do event streams handle duplicate events? Deduplication transformations filter based on unique keys or watermarks. Idempotent destination rights, e.g., upsert in EventHouse, prevent duplicate impacts. Exactly once semantics in supported connectors avoid duplicates at source. Custom filtering in Processing Editor removes duplicates in flight. 14. How do event streams manage scaling? Throughput settings configure ingress, egress capacity units for horizontal scaling. Fabric capacity autoscaling adjusts compute based on workload concurrency. Partitioning in sources distributes load across parallel processes. Monitoring metrics guide manual or automated scaling decisions. 15. How do event streams support monitoring? Data Insights tab provides real-time metrics like events per second and backlog. Runtime logs capture warnings, errors, and info for troubleshooting. Workspace monitoring aggregates event stream performance across items. Integration with capacity metrics tracks consumption and anomalies. 16. How do event streams ensure data security? Workspace RBAC and item-level permissions control access to streams. Managed private endpoints secure connections to protected sources. Sensitivity labels and endorsements propagate governance. Encryption at rest and in transit via Azure standards. 17. How do event streams handle event replay? Retention policies store events for configurable periods up to 90 days. Replay from buffered events supports recovery or reprocessing. Custom endpoints allow seeking to offsets in Kafka mode. Pause and resume maintain state for controlled replay. 18. How do event streams support multi-consumer architectures? Multiple independent destinations route the same stream concurrently. Custom endpoints enable fan-out to external consumers via Kafka. Derived streams branch processed data to separate consumer groups. Real-time hub subscriptions allow multiple downstream analytics. 19. How do event streams integrate with Power BI? Direct routing to Lakehouse enables real-time dashboards via KQL queries. OneLake availability supports direct lake mode for low-latency semantic models. Streamed data in Lakehouse integrates with Power BI datasets. Activator alerts trigger actions visualized in Power BI reports. 20. How do event streams manage throughput optimization? Configurable throughput levels balance cost and performance. Batching and compression reduce overhead in high-volume scenarios. Early filtering and aggregation minimize downstream data volume. Monitoring identifies bottlenecks for targeted tuning. 21. How do event streams handle back pressure? Throttling and queuing manage overload from slow destinations. Autoscaling increases resources during sustained high pressure. Partitioning distributes load to prevent single-point bottlenecks. Alerts via monitoring notify on sustained back pressure conditions. 22. How do event streams support disaster recovery? Geo-redundant storage in Azure Event Hubs ensures durability. Retention and replay capabilities recover from outages. Multi-region capacities support failover configurations. Git integration and deployment pipelines enable configuration recovery. 23. How do event streams manage retention policies? Configurable retention from 1 to 90 days buffers events automatically. Events auto-purge post-retention to manage storage. Destination-specific policies control long-term archival. Settings apply at event stream level for consistent governance. 24. How do event streams control costs? Capacity-based pricing with pay-for-use on active data flow. No charges during idle periods exceeding 2 hours. Monitoring tracks consumption units for optimization. Throughput tiers and retention tuning balance performance and cost. 25. What are best practices for event streams? Enable enhanced capabilities for full transformation support across destinations. Use modular-derived streams and multi-destination routing for maintainability. Implement early filtering, partitioning, and monitoring for performance and reliability. Leverage Git, CI, CD, private endpoints, and retention policies for governance and security. Thank you for watching. If this video helped you prepare for your Microsoft Fabric interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth data engineering, analytics, and cloud technology interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.